Okay, so I'm going to create a VPC. Let me create VPC only. So this would create it automatically for you, but now we want to create it by ourselves so that you understand when you create it by yourself. So here I'm going to call the VPC Kefa VPC. That is the name of my Kefa VPC. Yes. So I'm going to create it. And then we're going to input our CIDR range. So CIDR range, we are going to most likely the best thing. One of the things about CIDR range, it has to be a private IP address. So this is the most simplest one is 10.0.0.0 slash. Let's give it a slash 16. Everybody here who has been here knows that a slash 16 means the first 16 bits are fixed and then the other 16 bits are actually can be flexible to give a total of 32 bits for an IPv4 address. So we are creating a VPC. So now that we have done that, now our VPC is created. So this is our VPC created. So our VPC is named Kefa VPC with this CIDR range. Now, next thing we're going to do, what do we need to do next? Now that we have a VPC, so the next thing we want to do with this VPC specifically is what we want to do. We want to input what we call a subnet. So when you have a virtual private cloud, you have different things that you want to put into your network. You want to put in maybe 3 EC2 instances. You want one to run that web server, print server, or anything, or you want to put in something like a database that is running on a serverless database, DynamoDB, or let's say Amazon Aurora. We haven't talked about that one, but we're going to talk about it. So those are what you call self-managed, fully managed databases. So what do? You need to create a subnet for it. And one of the things about subnet is that they are particularly, especially databases, should not be able to be accessed online by people. So you need to put them in a particular subnet that they're protected. So in this case, we're going to create what we call a subnet. So we're going to come here and then we're going to say, let's make this a subnet. So we're going to say, let's call it public subnet. So public subnet is basically just a subnetwork, subnet. So we're going to add a drawing and then call that is a public subnet. So that means it's public. This one can be accessed by over the internet. Then we can also create a second subnet for in case we want to input databases and call it private subnet. We call it private subnet. Done. So we have a public and private subnet. So here we can input things. This has direct access to the internet. This should not have direct access to the internet. So that is one thing. Next. So we have a subnet. So now that we have the drawing, we have to put it. So we don't even need to put input. I'm just talking about a private subnet. But public subnet we want to, because we want to be able to access our Nini. So what are we going to do next is, we're going to create our subnet. So one of the things I want us to do, I want us to click on a VPC. Let's click on the VPC that we've created so that it's Nura Mohammed. Why does she keep leaving the meeting? Huh? Especially when things get hot. It's almost like every time we get hot, Nura leaves. Mimi hata sijui iko aje sasa. Kefa VPC. So when you select a VPC, it will only give you the resources that are linked to that virtual VPC. So from there, next we go to subnet. So we want to create one particular subnet. So let's create subnet. Then because we want this subnet linked to this our VPC that we've created, then we let's even call it public subnet here, because it's just me here. So I can call this public. I can call this public subnet. Yes, I can call it public subnet. Then I want to put it in what we call an availability zone. An availability zone is just one particular place, data center that is fully managed and it has its own source of power and all backup. So we put it in, let's say, Northeast 1. We can also replicate this to another availability zone in case something happens to the first availability zones. Okay, so the next thing we're going to do is we're going to enter the CIDR range for our particular subnet. And we know the CIDR range for the network VPC was 10.0.0.0/16. So our CIDR range here needs to be 10.0. The first 16 bits should be fixed. Then we can add this second .0.1.0. And then we can put it to /24 so that it is inside the VPC CIDR range. Yes. So that is one thing we talked about to Shajue here. So 10.0 has to be fixed in order to match the CIDR range for this. And then using Zingine, the last 16 bits can now be, they can now be flexible. So we create a subnet. So after creating a subnet, here we are. So we have a specific subnet. So now that we have a subnet, the next thing we want to do to this, so this is a public subnet, and this public subnet needs something. What does it need? It needs, now a subnet is a subnetwork, and we're going to put our resources inside the subnet. Now the resource that we're going to put here is what we call an EC2 instance. Now we want to be able to access it. But before we input it, one thing I want us to do is, I want us to, in order for this VPC to be able to access the internet, it needs a gateway, like a gate. So like if you have a parking lot, in order to be able to get out of the parking lot, there needs to be a doorway. That is the same thing as an internet gateway. You need to have an internet gateway to get into the internet. Yes. So this is what we're going to do. So we're going to input our gate slash internet gateway. So we're going to come here and say, click here, internet gateway. Then internet gateway, we're going to create an internet gateway. Then I can say, let's call it Kefa IGW for internet gateway. Then you're going to create an internet gateway, right? Then after creating the internet gateway, if you create a gate, a parking lot, what do? You need to bring it and install it there. So you can't just create it. You need to attach it to the VPC that you want. So I'm going to click here and attach it to the VPC called Kefa VPC. Then I attach it specifically. So now, so now basically I have an internet gateway, and I can come here and say, let me call this my IGW. So this is my internet gateway. So IGW. So I have attached this to the VPC. So now we have a way for actually us to access the internet from outside. So now that we actually can access the internet, where does this traffic route to? So when the internet comes in, there is nowhere for it to do. So what we need to do is we need to route traffic specifically from the internet, because we have a private subnet, we have a public subnet. So if the traffic is coming, we want to make sure the traffic from the internet goes to specifically the subnet that we want, which is the public subnet. It's not supposed to go to the private subnet because it's private, and it's not supposed to be accessed. So what do we do? The next thing we're going to do is we're going to route traffic from here to here. So we need to create route tables. So if we come here on route tables, yes, if you come here on route tables, let it load. Now we can create our own route table. Yes, we can actually create our own new route table and say this route table is for this. Or for things like public subnet. So things like this is a public subnet. This is the public subnet. This is the VPC. So the VPC created its own default routing table. And so we can create our own route tables, or we can actually edit the default one. So in this default, we have this 10.0.0.0/16, which is a local route table that routes data within the virtual private network. Now, the next thing we need to do is we need to edit routes so that we add a route from that takes data from the internet, yes, to from the internet to specifically to target, from the internet to the IGW, which is the internet gateway. So we're going to add a route here, 0.0, and then we need it to be routed through the internet gateway. Let's see, internet gateway. So internet gateway. And if you come here, we have the internet gateway that we created, which is called Kefa IGW. So now we have destination. So so basically what it means is this is the target. So the traffic needs to be routed to the internet. Yes, we need traffic to be routed to the internet. Destination 0.0.0/0 is the internet, and then target is the internet gateway. Then what we do is we create it. And now what we have done is, if you can see here to the route, we have the local routing within the VPC, and then we have 0.0.0, which is routing to the internet as the destination. Now, after creating this routing table, what do we need to do? It doesn't do anything specific for us, because we need to be able, we need to route that data from the public subnet to the internet. And what do we need to do? We need to associate our public subnet to that particular route. So we come here to subnet association, and you can see here we say explicit subnet association is 0. So it means we haven't associated any subnet to our specific route. Yes. So subnet without explicit it says this public subnet has not been explicitly associated with any subnet. So in this case, we edit subnet association, and then our public subnet is what we click here, and then we say save associations. Boom. then now we have actually we have actually linked, yes, we have actually linked our how do you call it, our what is it, we have actually linked our what do you call it, our subnet, public subnet, to this particular routing table. Okay, now we have this. What is the next thing that we need to do? So we have subnet done, routing table is done, internet gateway is specifically done. So the next thing we need to do now, I want us to create network ACLs, but I don't want to create it now. I want us to create it later because I want to use it to demonstrate. Now, what is a network ACL? So basically, right now we have actually routed. So when we added a route, so it's basically this. Let me. Mhm. Okay, fine. I can just come here and see. Mhm. What the hell is going on? Kwani mimi ndo sijui kufanya nini? Bwana, mimi sitaki hizi vitu nisumbue bana. Hizi ni tabia gani? Ah, bana, fuck this shit. Okay, so basically we know by adding a route, we know that we are routing this public subnet to this. So a line should go there. Bana, kama utaki siuache. Acha tuangalie. Yes. Uh-huh. Wow. Wow, really? Come on. Heh. Kaya na Yesu bwana. Me, I don't care that shit. It's really giving me the creeps. So just put an imaginary line routing the public subnet to the internet gateway. The private subnet has not been touched. It's still nothing. Now, the next thing now we want to do, we are going to talk about ACLs. Now, ACLs are what we call access control lists, and they basically act as a firewall around each subnet. Yes, each subnet. So I can create an ACL around this subnet. For example, I can create this. I can create this around this. Yes. Then I can say this is the color, and then I can say send to back, send to back. And do this. I can also do another one. I can also actually I can actually do here. I can do this, and I can say send to back. Then I can say send to back. Yes. So now you can see that here. So an ACL is basically it's basically a firewall around each of these subnets. So it specifically filters which kind of traffic you want it to go here. So in this case, you specifically. So if you want only HTTPS traffic or only SSH, you basically do it. What we call an access control list. But we're going to do it later because we're going to use it to test something. Remember the other time we've configured it earlier before. So now that we have a way to access the internet, and now we have what we call a public subnet and this. So we want to test if we create an EC2 instance and put it in our public subnet, will it access the internet? So what are we going to do? So we're going to come here and say EC2. We're going to create an EC2 instance. And one of the things we talked about that in the EC2 instance, when you create, we have what we call a security group. A security group is also a firewall, but instead of it being around the subnet, it's specifically around an EC2 instance. So if you have an EC2 instance here, you have a security group around it, then you have a subnet, then you have an access control list. So if I come here and say, okay, now let's launch an instance. I want to launch an instance. This is what I'm going to call this a test instance. I'm going to call this a test instance. And then what I'm going to do is what I'm going to do. Now, before that, let me see. Before that, I want to create something. Before that, I want to create a security group. So let me see if I have a security group. I want to create a security group. I want to create a security group. Yes. I want to create a security group before that because the security group imekuwa ikileta shida. I think maybe it was the one thing that ilileta issue because security group ilikuwa not specifically. So let me select Kefa VPC. Then let me come here and create a security group. Security group. Now, security group. Let me do security group. So now I can create a security group. Let me call this security group Kefa SG. Kefa SG for security group. So this one basically, it means it's a firewall around my C2 instance. Then description, I can say it should allow HTTP, HTTPS, and in case I need it, SSH traffic to go through it. And then I have to specifically pick which instance. This is the part that I think tulikuwa tuna mess now kidogo, but let's see. We have to specifically pick. It needs to be security group linked to the Kefa VPC. And then what we need to do with one of the things we said about a security group, the difference between an access control list and a security group is that a security group is stateful. It's stateful, meaning when you create outbound rules for them, they remember. When you create outbound rules, when you create inbound rules for them, those same rules are applied for outbound. So if I create that allow HTTP traffic, then it will create a rule to say allow that HTTP traffic to leave as well. The difference with that and access control list. So in an access control list, when you create something like allow HTTP traffic, then you have to actually go to the outbound rule to say now let it go. So if you don't configure outbound rules, then HTTP traffic will come in and it will never leave. Then you probably have something that can't communicate. So we're going to add rules. So the first rule, I'm going to say I want HTTP. I want to allow HTTP. Then HTTP, I want to allow from anywhere from the internet. So 0.0.0/0, we say that this is the route for the entire internet. So we are allowing HTTP traffic from the internet. Then we're going to add another one. We will allow HTTPS traffic also. And we said HTTPS traffic is just a secure version of HTTP. So we're also allowing that from the internet. And then we are adding a rule to say SSH traffic, and we're going to allow SSH traffic also from the internet. Now, it does not always have to be like this, because you might actually only want to allow that traffic from your specific IP address. So if you need it from your specific IP address, choose your IP address, or you can make it custom so that you customize it for only for an IP address that you need. So if I do this, you see the outbound rules have not been configured. But let's do create security group. So security group is being created with 3 things. So this is the inbound rules. We have inbound rules allowing HTTPS, SSH, and HTTP, HTTPS, and SSH. So outbound rules. Okay, let's see outbound rules come as you may configure. Have they been configured? For some reason, they haven't been configured. That is not supposed to happen. Yes, for some reason, because security group is supposed to be stateful. I'm not sure why they haven't configured yet. So IPv4, this is allowing all traffic. So this is configuring allowing all traffic. I don't want to allow all traffic. That is just shit. So this has actually configured all traffic has been configured. So because this is what we call an outlier, let's not nini. Somebody wants to say something? Let's security. Duncan Hillary. So because that is an outlier, let's delete that and let's add a rule. So we're going to add a rule for everything else. So obviously HTTP that custom internet protocol version 4 everywhere. We're going to have HTTPS TPS also internet protocol version 4 everywhere, and then you're going to have SSH as well. And we're going to have SSH as well, and then save rules. Okay, it needs to be from internet protocol. Don't use IPv6 yet. IPv6 is probably a little bit weird. It's one of those very weird. So we have configured a security group that is called Kefa SG. So the next thing, let's create an EC2 instance. So let's create an EC2 instance, and then boom, we're here. We're creating an EC2 instance. So let's come here and launch an instance. After launching an instance, let's say test instance. We are going to use this to test. Then after that, we're going to use Amazon Linux or AMI for this. We're going to use our default T2 micro. And then in this case, I have my key pair is auth0 because I believe I have it here. cd credentials and then ls. I have auth0.pem. So I can just say chmod 400 for that to allow for read. Then we're pretty much good. So the next thing, we're going to edit network settings. Very key. So in this case, we are going to specifically specify our Kefa VPC, the one that we want. Kefa VPC. Yes, Kefa VPC. And we're going to specifically consider, we're going to allocate it to the VPC Kefa, and then we're going to allocate it to that public subnet that we created, 10.0.1.24. And then we're going to allow it to auto-assign public IP address. Yes? Good. And then when you come to this firewall security, I want us to select as existing security groups, and then I'm going to use Kefa security groups that I just created. Then from there, I am pretty much okay. Now, the next thing I want to do is I want to add some details on the user profiles, a bash script. And I've created a bash script right now from on VS Code. Let me pick it up, VS Code. VS Code. Where is it? Please don't tell me. Please don't tell me. Where is it? Yes, I have this. So I have taken this. So here's the script. So I hope you guys can see it. I hope you guys can see the script. So it is a bin bash. It is a bash script. And basically what it does is, first thing, it updates Amazon Linux by saying sudo yum update y. So y, just say yes to everything that comes in. Second is install Apache server, which we all know that is sudo yum install httpd. And then the y says that anything that says yes or no, we just say yes to it. Then we start Apache server, which says sudo service start http start. Or okay, that's actually starts it. Or let me use the one that I'm used to. Sudo start, sudo system ctl start httpd httpd. Okay, so that one will start Apache server. Then next, I want to install Git. So I want to say sudo install git y. I want to install Git, so version control system. Then after installing Git, it's because I want to clone this repository that I found online. And then after cloning that repository, it's going to give me a repository with a directory T house. So then what I need to do is I want to move everything. Star means everything. So I want to move star every file that is in the T house directory to this directory called var www.html. This is where you put files if you want them to load as a website. So this is a basic template HTML. So let's launch an instance. So an instance is launched. If it doesn't work, maybe Mungu too, because I literally just did it. Right, I got time just a little bit earlier and just did it, and it worked. And I don't know why it stops working sometimes. So we're going to wait for it to pend, to load, 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 to load. So it is running. So now it is running. So it's still going to do other things. So we have a public IPv4 address. Then we can copy it here. I know it's going to take time for it to public IPv4 address. Okay, still. Let me just hope that it's because it's still installing Git and installing all that stuff. Because if it's yes, see, it says it works, right? It means at this point, imefika kwa ile point yenye it has done what? HTTPD. It has installed Apache server. So we're supposed to reload and wait for it to download Git, install it, to clone that repository. After cloning that repository, it's supposed to do what? Something. It's supposed to clone repository, and then after cloning it, it's supposed to copy all the files inside it to a different thing. Let's see. Okay, so it's loading pole, but this already shows that our network really definitely actually works. So if it works, this shows that Apache engine works. So it means wherever our EC2 instance imekuwa placed, our EC2 instance can actually access the internet and everything is working fine. Well, let's reload. Let's ngoja kidogo. I really hope. Ama I need to do something else. Ama maybe I need to do T house. T house requested URL was not found. Okay, maybe not. Let's just wait for HTML. Come on. Okay, Okay, let's wait. Maybe we need. So check says they have passed. Check says they have passed. But now the good thing is that now our Apache server works, so it means we can access this sheet from the internet. So that also means that we can actually access it via SSH. So if I come to SSH here, cd credentials. You remember the other one could not access via SSH because the network could not see anything. So what do we need to do? Okay, so what we need to do is SSH /I, and then passing the auth PMC, passing the authentication key, and then say EC2 user, and then then let's copy our public IP address. Public IP address is here specifically. Let's copy it 54. 54 public IP address, 54 paste. SSH high, yes. So the fact that that works, it means our thing we can actually access it because we allowed SSH from the internet. So ls. Now let's see what is happening. ls a. So in this case, okay. So let's say cd. So what happened? So let's see. Let's see pwd copy. EC2 user. So let's see CD, which is the VAR part where, and then WW. No, it's VAR. Sorry. CD VAR LS. I believe we have WW CD then WW. Then LS CD HTML. So see, nothing happened. It means nothing was copied here. So what we need to do is let's go back to our Linux this. So something did not copy there, Paul. So let's go back to what we did. So let's use Git. Let's check if Git is installed, Kwanza. So Git is installed. So let's clone that thing when it will go now, because it seems like that part didn't happen. So if we come here and say paste, so if I say git clone, I guess if I say, okay, I guess if I say sudo git clone, sudo git clone. So cloning t house, and then so t house. So I believe if I do here and then say t house, see, now it works. So now it's loading rental services. You see, it's now actually loading rental services. But in that case, I need to put it in a root folder. So it's t house. So I'm going to say, so let's just use sudo mv let's see t house sudo move t house, and then dot, let's say dot, where is dot, oh sorry dot. So sudo move, I'm moving everything inside the t house directory, and I want to move it to this particular directory right now, and I want to move it to this particular directory. Let's say that this directory. Let's see ls. Okay, let's see pwd. Let's say pwd. Move pwd. So I don't know, var html. Move html t-house move. If it's going to misbehave like that, let me just use long format, fac long format, copy sudo. So if I move, let's say paste, if I move everything from var html, what is going on? Yes. T house. I move all. Move everything. Star. So the move star is supposed to mean all. To var HTML. So just copy this. Should be okay. Should be okay. Copy link address. Let's see. Let's see, paste. Okay. MV target is not a directory. T house. And this. Oh, ww and no. I think so. Just var. Let me just do var. Sorry for misbehaving. var. ww dot html. Alas, please tell me it copied. Yes, it copied. So that in that case, if I come here instead of no x, if I come here instead of actually putting t house, then it is now at root. So I can just do this, and then rental house services can now come here. So did you guys see how that happened? So this is the HTML file. So now the rental services just comes here. So okay. Don't do that. Don't log me out, you little shit. Where are we? Are we guys here? Let me see. Yes. So did you guys at Kosa? No.
Yeah.
Yes. So I want to now install the access control list. Now I want to install the access control list. I want to install the access control. Let me put my authentication, my factor authentication. So my two-factor authentication, that is multi-factor. Where the hell is that? Brian 210. Okay, so here we have running. So now basically, Peter Lee, yes.
Is there a way to upload from your local machine?
To upload from?
Your machine or like local resources.
What exactly do you want to upload? Like you want to upload something from...
I'm thinking of an example of maybe a web app that has like databases, and I'm not sure if putting it on GitHub is like really secure.
A web app that has databases. So like the database, see, you can just upload the data. See, if you're doing it as a database, then let me see. As a database, it has a database. Someone who may download database as .sql something.
No, like iko na database. So like wewe ukiinput data yako inaingia. Sasa see, it has to be connected.
So you can decide. See, if you have a database, yes. If you have a database, number one, you can migrate your database specifically. You can migrate your database from Maliiko and then as a .sql, and then you can upload it. You can upload it to your EC2 instance. You can upload it to your EC2 instance. For example, if you want the database to run on EC2 instance, then after installing it on your EC2 instance, then now you can actually go. For example, if you install PHP MyAdmin on the EC2 instance, you can actually upload it, import it there, alafu ifanye. Yes. Or if you're going to use something like a fully managed system like Amazon Aurora or DynamoDB, then those provide an automatic way to import your databases. So there's no need. You don't put your database in GitHub. The GitHub is just for the files, the static files and all that stuff. So this was just a static file that I was just using to show you basically how you can do it. So, or if like see, that was GitHub. You see, you remember I talked about the wget command, yes?
Yeah.
Yes. And plus GitHub, you can put your GitHub private. Just don't put things on GitHub such as your keys and all that stuff. But let's say now
I
want
have
to
like local files. Maybe I can try hosting.
What?
I have I've built a couple of websites, and like so I can host it from my machine. I can like
Okay, so if you want to put them on an EC2 instance,
yeah,
just come if it's an If it's the static ones, zimebuildiwa na nini?
JavaScript, CSS, HTML. Sijaweka vitu mingi sana.
CSS, HTML, hiyo ni sawa. You just upload it on GitHub, make it a private. If you don't want anybody to see them, just upload them on GitHub, make it private. After making it private, you can just clone them to the EC2 instance, then they run. And then if you want to take care of your databases, you can just you're using which MySQL databases?
Okay, sijaweka database bado kwa nini, but
Kama hakuna database, then you're pretty safe. There's no biggie. You just upload them on GitHub.
alafu last time we didn't do with the auth key.
We didn't
Kama
do?
hatukuweka auth key.
Oh, yeah. No, the auth key, the authentication is used only when you want to SSH. So in this case, I needed to SSH in case shida ikuje like this. You know, Nasai, like after running that particular bash, after running this bash command that I showed here, let me show you. After running this bash command, we realized that the move command ni kama ilikuwa imekata. So dash home. So it was supposed to be dash home EC2 user T house. Then it's supposed to move everything here to the var www.html. So here haikuwa imefanyika. So I needed to SSH to check if it happened. So SSH specifically is used when you want to, log in and check things. Your HTTP, your EC2 instance will still show if you don't SSH, because at that particular time, the only thing we wanted to do was to make sure that our EC2 instance could be seen from the internet, which happened. Layer 2, I just wanted to add something extra. So one thing I want to ask before to Nini is access control list. We used access control list last time. So let me see. Let's go to a VPC. Then we have a VPC upper. We have a VPC in this case. Let it load. I'm using Tokyo. So let it load. So let's look for access control list. Now access control lists are here. And one of the good thing, always try to select your specific VPC so that it only filters the resources that are yours, that are based on yours. Yes. So this is what we call this is a network ACL. So you see this ACL. Apparently, it creates a default access control list, and you can see this is a default access control list that has been created. Yes, see, and if you open it up, no, that is showing us the VPC. We don't want the VPC. This is an access control. Where the hell is it? Go to about access control list. So this access control list were created by default, and if you go to network access control lists, and then we look at let's see, we look at these rules. If you check out the rules, inbound and outbound rules, they have one specific command. They're saying allow. They're basically saying allow. They're giving allow all traffic. Yes, they're allowing all traffic to this particular server. So what I want to do is I want to show you that they actually work. So actually, one of the things you're never supposed to do is to allow all traffic to your particular, thing, even if it is a public subnet. So one thing I want us to do is I want us to go here, and I want us to do this. All traffic, I want us to do something called all traffic deny. Then I want us to do save changes. Yes, I want us to save changes so that you see what basically an access control list does. Let's also go to edit outbound rules, and then let's deny all traffic so that we save changes. Yes. So if we do that and then start reloading, let's wait for it to reload. So it will reload and reload and reload and reload and reload forever, because now it can't. The access control list around the subnet is not allowing any traffic to either go in or go out. So that is basically what the network access control list, the access control list is. It's specifically so depending on which subnet you have, you might want to only allow specific kind of traffic. For example, on a private instance with your database, maybe the only thing you want to be able to do is to access it via SSH. You only want to be able to be accessed by SSH, because SSH, you have a public key up there and a private key which only you have. So you're the one who can access it safely. Yes, so you can actually access it. And let's just go back. So let's just go back and come back and say, let's edit inbound rules. So if you come back here and edit and say allow and save changes, and then we come to outbound rules and then edit outbound rules, and then click here and say allow Save changes. And then we give it a little bit of time. You see now it reloads. It's because now it can allow actually that traffic to go. But one thing we've said that never, never, never do allow all traffic because that is bad. What you need to do is remove this and add a new rule. So just add a new rule. Use numbers. So like you guys know, I like using 100 as rule number. So the rules are actually implemented according to which one comes first in terms of numbers. So HTTP can say HTTP allow HTTP request. I can add another one 101 and then say HTTPS that, and then I can allow, maybe I want to add SSH. Let's see 103 can add SSH. Perfect. So I can just say this, save changes. And like I said, network access control list, they are stateless. So you have to do the same exact thing for this other side. So remove that and then add a new rule. Can still give it also again 100 HTTP 80. And then I can add 101 again. I put HTTPS there, and then I can add a new rule and then say 102 and then say SSH and SSH in that case. Then I save changes. Yes. So that way it will still load because this is HTTP. This is HTTP request. So it should still load. I believe, yes. Should still load, I believe. So loading. Why is it not loading? Let's see. It's not loading. That's some bullshit, I guess. So 101, 102, 100, 101, 102, 103, allow, deny. Urban rules nimeweka. All traffic deny. I don't know why it's denying something. Something is wrong. Edit urban rules. So all has been allowed. I've allowed everything. HTTP 101. Okay. Let's say 200. Say 100 and let's say 200 to 1. Let's say 202. I don't know why it's 203. 1 to 2. Let's say. Yes. So, let me see. So this is it. Then subnet association. Yes. So this has already been associated to our public subnet. So that's okay. That's okay. It's already been associated to our public subnet. So at this point, what kind of traffic do we have? So for some reason, it's not allowing all traffic. It's not allowing traffic. So this is HTTP because I can see we're not secure. So this is HTTP traffic. So I'm not sure why it's misbehaving. Outbound rules, inbound rules, outbound rules. Okay. So let's see, edit outbound rules. All traffic. You can see if, let's see what happened. Let's see. All traffic allow. Let's say one. Let's come back here. Inbound inasema allow. It's outbound. Let's see, outbound inasema okay, allow traffic. Sema allow. Okay. Cancel. Inbound. Let's see, remove. All traffic and deny. Add new rule. Let's say all traffic and see. Must be a number in the range of 1. Let's see. Okay, something is wrong. I have no idea why. It's only allowing that, but fuck it. For the moment, let's just leave it at allowing all traffic, which is a very bad way of implementing. I'll go check out why the hell that is actually happening. So we're done. And then one thing I want to talk about before else is that, for example, if this is a private subnet, yes? Are you listening? So if this is a private subnet, maybe you have another EC2 instance here, and for example, you have sudo. Let's say, what do you have? We have let's say this. So this is a private subnet. Yes, this is a private subnet, and this is a public. Now we know that the routes only allow this to go online and leave. This one can't access the internet. What about this is an EC2 instance running Amazon Linux, and it's been 1 month, and you need to update sources? What do you do? Somebody think of something. What do you do? Now you need to access the internet on a private subnet, because you need to update Linux sources, repository, you need to do sudo yum update. What do you do at that point? Yo, Peter Lee, come on. James,
Sijaelewa. Pardon?
si tumesema public subnet ndo iko na direct access to the internet gateway to the internet.
Yeah.
Private subnet not. And we say a private subnet is a subnet that does not have a direct route to the internet. So it's not connected to its routing table, does not route to the internet. So what happens if at some point we want to update things inside the private subnet that will need the internet? What do we do?
You can make it public or something. You can also use NAT, I guess.
You can't make it public. That is wrong, because it's already making it public. It compromises this. So what you need to do is we need
Use
to
NAT.
introduce what we call a NAT. We need to call what's called we need to install what we call a NAT translator, network address translator. Yes, this is what we have here, what we call a NAT gateway. Now, a NAT gateway, we are going to create what we call a NAT gateway. So you come here and create a NAT gateway. Let's say Kefa NAT. And then, now the NAT gateway, one thing you need to know about NAT, you attach a NAT gateway to a public subnet, not to this, not attach it to this private subnet. So because you're going to attach it to a public subnet. Somebody ask me why.
Why?
Because it's linked.
If you don't ask me why, I won't answer. So you've asked why. You attach it to public. This is the one that has a route to the internet. So what we're doing is that we want this to go to this. We only want this to access the internet. So the NAT is supposed to link this to this. So this is supposed to get internet from this and this directly to this. So we have a mediator upper. So this is the guy. So even if somebody wants to attack this, they would not be able to, because they can only see this guy, and then this guy serves this to this. So when you create a NAT address translator, you use it on a public subnet, of which I didn't even create a private subnet, by the way. Before we do that, let's go back to VPC and create a private subnet, for example. We didn't create a private subnet. So come here to a subnet and then say create a subnet. So in this case, let's say create a subnet. Say select it to a VPC and then come say Kefa. Let's just call it private subnet. Yes, then we can do it still in the same availability zone, and then we can use 10.0. We know those are fixed. Now 2.0/24 CIDR block, and then we say create new subnet. So now we've created a subnet. This is a subnet. We're supposed to call it private, but we know it is not private or anything. The only way you say a subnet is private is if it is not routed to the internet. So a private is actually all default subnets are private because they're not linked to an IGW. So you only say a subnet is public when it is linked, the routing table links to an actual internet gateway. So now in this case, we want to create a NAT address translator. For example, this is a private subnet. So what do? You call NAT gateway. Yes, we call a NAT gateway. So one thing I want us to do first, yes? So I want us to test this shit, yes? I want us to test this shit. So let us create another EC2 instance. We want to put this EC2 instance inside a private subnet, yes? And we're going to try to check if we can update anything. So EC2, let's create an EC2 instance. Come here and create an EC2 instance. We come here and create an EC2 instance. And then let's say a private EC2. Private EC2, for example. So we want to test. Then everything else comes default. Key pair, let's just use auth0 because we want to try to access it via SSH. So in the network, let's edit. So we are going to come here and say Kefa VPC, and then we're going to add it. We want to add it to a private subnet, the one that we've just created. Then we're still going to select the existing security groups, which is Kefa security groups. Every other thing is going to actually work. Is actually going to work. So one thing we want to do is we don't even want to put any of those profiles. So let's just say launch. So we want to launch it. Now I want to launch it. So we are launching the EC2 instance. So we come here, EC2 instance, we launch. Okay, so where is the Linux terminal? So for example, oh, sorry. Oh, yeah, so this imekufa, imeenda. So what we're going to do is Control T. Let's create another Linux terminal. CD. What you do is CD. I have my credentials. And then that one has already been given a CH mode. So now let's try and see this. So now we have private instance running, Cindy. So what do we do with it? No way, no way. Did we? No, we didn't. I needed it to have a public. Let me see. It doesn't have a public IP address. So terminate. We didn't assign a public IP address to it. So let's terminate it and create a new one. We didn't assign. We forgot that part. So we're going to come here and say we're going to come here and launch an instance. Then say private instance. And then we're going to come here. Everything is default. Key pair, we're going to say auth 0. Then we're going to come here with the network. Network, we're going to check it to Kefa VPC, and then we're going to say to private subnet. And then Apaco auto assign public IP should be enabled. That is what we did not do right. Then if we click here, we're going to select a security group by Kefa, and then we are done. Everything else is set. So we can now launch this instance again. So always remember to assign IP address to a public IP address to your Nini. Now, in case you have gone far enough that you cannot actually assign a public IP address, the next thing you can do is you can come here and click on Elastic IP. With Elastic IP, you can allocate one Elastic IP, then you can say allocate. It will give you an Elastic IP. Then after that, you can come here and say associate an Elastic IP with an EC2 instance. So which the EC2 that you did not assign, you can click on it, and then it can actually allocate an Elastic IP to it. Now, one thing about Elastic IPs is that they actually cost money. So as long as you're not using an Elastic IP, you need to release it back to Amazon. Amazon has those, so you release it back to Amazon so that they can assign it to somebody else. So always make sure when you're done using an Elastic IP, you give it back, because if you're not giving it back, even if you're not using it on an instance, but you still have it, you haven't released it, then you're going to be paying for that particular service. So beware. So in this case, we have EC2. We have an EC2 instance. So we are here, click on EC2 instance, and then we have the running ones. So what is the EC2 instance that we have? We want to test the private EC2 instance. So we're going to click on it. We're going to click on it here, and then we have its public IP address here, right? This is the private instance. So what do we want to do? We already have it here. So we have auth0.pem. So we're just going to say SSH. We all know eyes. It doesn't matter whether it is small or we're going to pass in the pem. Then we're going to say EC2, then the user, and then we're going to say @, and then we're going to paste our public IP address, which is paste. Yes, and then we're going to enter. Should work. Yes, and then we're supposed to say yes. So basically, we can actually SSH this. We can actually SSH. Yes. Now, the next thing is, can we get the internet? So we're going to say sudo yum update. Okay, I'm not sure if it did, but let's say ping, and I did something, google.com. Okay, so you see we're pinging google.com. Google.com is not coming. Google.com is not pinging because it can't get the internet. Yes? Tunaona? Are we okay?
Yeah.
Yeah. So it is in a private subnet. So we can't actually access the internet because we're in a private subnet. So what do we want to do? You say the other one, make it public, but that is a security compromise. So what we need to do is to create a network address translator, assign it to a public IP address. Then we're going to create a route table. And then we're going to link associated to this. So let's leave that on there. So next thing is you're going to come here and create a network address translator. Where the hell? Let's go to VPC. Go to VPC. So when you come to VPC, let's specifically select our VPC. We want to know what we're dealing with. So Kafka VPC is pretty good. So we're going to say NAT gateway, create a network address translator gateway. Then we can say Kafka, obviously a Kafka NAT as well. Then we want to select the public subnet, not the private one. Yes. And then Elastic IP, allocate Elastic IP. So allocate Elastic IP for it, and then create a NAT. So this is a NAT. So this is a NAT. So state it is still pending. Primary IP4 address pending. Create a NAT. Network address translator. State pending. So let's wait for it. It is still pending. Okay, the next, let's go to route tables. Now we go to route table, let's create a new route table. Yes, let's create a new route table and then call it private route. Let's call it private route table. Then you're going to select Kafka VPC, and then you're going to create this private route table. Now the private route table actually comes, the private route table usually comes specifically, yes. It comes specifically private route table. Okay. Private route table usually comes specifically with what? What do you see? It comes specifically with destination. So this is the local routing, and then after that, now we have routes. Yes, and then we're going to add a routing. So what are we going to route? We're going to come here to add a route, and then in that route, we want destination to be the internet, and then it needs to pass through what we call NAT gateway. And then NAT gateway is this Kafka NAT. So we are routing to the internet. It needs to pass to the NAT gateway go to the internet through a NAT gateway. Then we click Save Changes. So NAT network address translator. And then after that, now we can now associate this route specifically explicitly to the private subnet that we have. Oh my God. Let me see. What is the subnet? Let me see subnet. What happened? I think I missed something. 10.2. Oh, okay. I thought we okay. So I thought that was an overlapping CIDR. So I think we're supposed to be good. So let's see. Where the hell was that gateway? Not gateway. Not gateway. So available. So let's try again here. Now we have okay, we may hang tenor. Usually in a timeout. So it means we have to CD to credentials. ls. Okay, yes. So now if we do this, SSH. SSH auth EC2 user armor. Is that the right nini for this? Okay, maybe I have missed something. So let's go back to what was it? Private EC2 instance, because now it's not loading. So let's go to open link in new tab. Let's go to the EC2 instance, the private EC2 instance. We might be missing something. Private EC2. So if I go back to private EC2 instance, I come here and I check. I have this is the public one they have. Yes. Okay. So yes. So this is the EC2 instance. This is the EC2 instance now. So if I come here, I come here. Okay, so EC2 user add SSHI auth perm paste. Why is it not doing anything? Why is it not doing anything? Routing table, routing table, routing table. Did I use the right security groups? I believe. So SSHI auth perm this. Let's make sure this is still loading. Okay, that is still loading. So this is 54. 54 should not be doing anything. Something went wrong again. But Nisawa. SSHI auth perm EC2 54 that. I believe that is the instance for private. Let a private EC2. Okay. Which private EC2 did I get? This one should not be here. Should be this. Let's see. 54, 168, 104. Is this the one that I put in? 168, 55, 168. Okay. 55, 54, 168, 54, 168, 54, 168, 54, 168, 55. Okay, so SSH, something is wrong. I don't know why it's not routing, but fuck that shit. Inamaanisha nishaanza kuchoka. But we do get the concept, right?
Yeah.
Yeah.
Yeah, we do get the concept, right? So something I'm not sure. Shidan, easy if it once goes wrong, you probably won't see it until it goes. You go watch a nice movie, mind you, because the more you need, the more shit you get yourself into. I learned that the hard way. I'm a smart. Did I use Auth0 for this? Did I use Auth0 for this specific nini?
Yes, I think so. Wait. Niliona kaa ulitumia kwa hiyo ya private EC2, but I'm not sure for the other one.
Let's see private EC2. Let me try to connect via this so that we check. Let me just try to connect via. If it can connect via console, then shida ni auth ilikuwa mbaya. Let's see if it will establish connection. Yep, if it's not establishing connection, then something is definitely wrong. Something is definitely wrong. Something is definitely wrong. Something is definitely wrong. EC2, let's say route tables. So route tables, this is what? No, this is Kefa VPC. Kefa VPC. Private RT, Kefa VPC, public RT. Main, no. Main, hii ndio gani? Subnet, Kefa VPC. Subnet. So local routing to the okay, so this is what, and then if we edit routes, subnet associations. So private subnet is specifically associated with the what? Private subnet, okay. Associated with that, with a NAT translator, with its target is to NAT, destination to target. Okay, 16 edit routes. Elastic IPs. Let's see. The Elastic IP lipeano gani? Elastic IP lipeano NAT address translator. Ama ilikuwa ni gani? So we have it NAT. Elastic IP NAT address translator. Public IP. Okay, not cool. Okay, anyway, fuck this shit. Ikikataa ikikataa imekataa. I will probably think about it usiku. Ni saa ngapi? It's 9:22, yeah. Once I get dinner, I need to go eat. I need to cook. Man must cook and eat. So, guys, Peter Lee, did you catch on this part, how to load things? Because the good thing is that this is recorded, so you can actually go through it. At least leo sikuchoka sana, it backfired and nini. This works. So right now, what imekataa ni when we allowed both SSH HTTP on our access control list, ili jump load. So we just let it do all network, which is a very shitty way. So I'm going to check out why that happened, because that is not supposed to happen. But anyway, always when you're going to When you're going to present your project, that's when shit goes south. How shit goes south. So that's good. So Mimi, one thing I say that as long as I find one person in a class, mimi nitaendelea. Huyo mtu ndo tutamalizana na yeye. That one person. So everybody who was not here on Monday, did you already read the email that I sent? I sent about security. So Monday tunaanza security, right? You read that?
Yeah, yeah.
Yeah. So you see, next week is packed as fuck. Next week is super fucking packed. So I'm not going. I'm not going to need anything. So next week is super packed. It's security. Let me see. Let me see. I think where did I send the email? So I usually send the emails to myself as well, so that I can check out what people are doing. So next week we said it's super packed. For example, what was this? Yes, introduction to security, acceptable use policy, security lifecycle prevention, network hardening, system hardening, data security, public key infrastructure. Now, if you're in a computer science class, easy vitu probably umezisikia. But now we're actually going to do them practically the way we have actually finished routing right now. So everything here, you're going to learn what CrowdTrail is. Basically, how you're able to access logs, flow control, AWS. This is CloudTrail. We're going to also talk about okay, AWS config, trusted advisor. Literally, we're going to do all this. We're going to implement them in actual things. So our theory classes zinaweza kuwa very minimal. The reason why before we started doing the VPC, I had to actually do a lot of theory, especially on the network addressing, is you needed to understand how addressing works, so that when you start creating siders on your network, you know exactly what you're doing. Yes, but hizi zingine za next week ati prevention you do, hizo ni vitu tunaenda kupitia shwi haraka haraka, so that tuingie kwa practical. And I've actually never given an actual a practical assignment, so I should probably do that. Peter, what's up?
Niko na maswali mbili. Ya kwanza,
Yes.
is Azure the same as AWS? Like
No. They're two different providers, and they. Okay, one thing about it,
No,
Azure
nasema
and
processes yani. Process
no,
wise.
no, no, they're not. So you see how, let me see, OneDrive and Google Drive are. They're just those two. But if you grasp a concept on AWS, they're usually almost same, talking about the same. They use almost terms that are equal. They're just twisted kidogo. Google, GCP, Azure, and AWS. So if you learn one cloud concept, then it's easier to grasp the other one. It's going to be very simple. So now AWS is the biggest cloud provider. So if you can, after mastering all these things tumefanya, ukiingia Azure, it's going to be very easy for you to actually master. Yes.
The other question is, kwa hiyo website yako, you see when you make one, the house rent. When you make one, you create a title probably, si ndio? Na inatokea kwa the search bar part. Can you make it such that badala ya IP? Okay. Hiyo DHCP, hiyo yenye ina translate the IP to a name. Kama venye the IP ya Google
Oh, say it's giving a physical IP address 54. Can you translate it so that it becomes something.com?
Yeah, houserentservices.com, kitu kaa hiyo.
So, hiyo ndio kitu nakusumbua. That is what we call Route 53. We're going to talk about Route 53 DNS management. So Route 53 is how you're going to appoint. So I can actually go in, buy a domain right now on Namecheap for like $3. After that, I'm going to point the DNS to this Route 53. So I'm going to create what we call a hosted zone. So if you come here, you can create. These are things that we're going to know later, but I can just walk you through it a little bit. So if you create an hosted zone, for example, launch ad, or let's say peterleeke.com. So you're just going to put it there, and then this you're going to describe what you're talking about. So peterleeke.com, and then you're going to say you create that hosted zone. So it's going to create a hosted zone for you. So after this, now you see you have records. So you have an NS and SOA records. So as a person, you're going to add what you call a CNAME, NAME, all this. So you're probably going to add an A record and then subdomain, for example. In this case, you can just say, in this case, unaweza iacha hivyo, so that it just becomes peterlee.com. And then from here, you're going to come here. For example, you see now you're going to mount 54 and 50. Let's see. So in here, you're going to come, if it's Route 53, you're going to map this here, so that you only it's going to map that particular logical IP address to here. Then you come here and say simple routing policy 300 TTL is okay. So you just do this subdomain, or you can just do a dash star. So when you put something like a dash star here, it means it takes care of things like if somebody inputs www.everything. So it takes care of it and then just create a record. Then you're going to wait for DNS to propagate for a while. And then you see what we have here. So if you go edit hosted, no, sorry, come back. So you see now we are here. So ukikuja hapa and you click here, then you look at this. See, this is NS. These are NS records. So let me just log onto something like my Namecheap. Let me show you. Namecheap.com. When I log into something like Namecheap.com, I don't know. Okay, let me log into my Namecheap. So when I log on to Namecheap, sorry. Where the hell is my authenticator? Where the hell is authenticator app 688? Actually, reload. Okay, 656 button 656. So it's going to reload Apple. Okay, so this is a list of all my domain names. Shit, which one is expiring? Yes, Jana. Let me see which one is expiring. I'm not sure which one is expiring. Products. I have 2 products expiring. Oh, okay, Silver Spark Africa. Shit. SSL Silver Spark in expire. Shit. Okay, that sucks. My domain list. So if I come here, for example, I have one of those domains that I bought. You know how when you have a brilliant idea, you buy a domain for it, and then you never do the project. So Launchpad KE. So I can come here and manage, and then after managing, I come here, and then I come here Ukuchini. So right now it's using Namecheap web hosting, so that if I say Launchpad ke.xyz, ni xyz ama ni .com ama I'm not sure kama ni domain. Okay, ni .xyz. So here, okay, it's just showing to, this one is even showing me to bad manners. What the fuck? So in that case, what I do is I will come here. You see these records. I will come here to domain, and then I will create a custom DNS, and then I will add the name servers. So I come here specifically. Where the hell is that domain? I will come to that route 53. So the first one is I copy this, and then I come to domain, then I paste it there. Then I copy the second DNS, the second record, and then I paste it. There. I can add a third. Then the third one is here. Then I paste here. Then I add a fourth one here. I come here and paste. I paste it here. Then I say click. When I do that, it's going to propagate. Then it's probably going to take a lot. If yours goes fast, you might even have it in 1 hour. Second, this now means this domain that I bought is being pointed to this route 53 hosted zone, which has been pointed to this particular physical address that you're loading here. Yes. So that's how you do it. And now, this is HTTP now. This is HTTP. So if you want HTTPS, you also need a service called Amazon, how do you call it? Certificate manager, so that you can actually create your own certificate. So this is a certificate manager. So you need to be able to assign certificates so that you actually have SSL protecting your particular website. So this is where you're going to assign certificates. So you can buy or you can actually upload. Because I believe I have some certificates here. I have some certificates that I got somewhere for free. Where the hell are those certificates I have? I don't have them, then fuck that shit. Code, keys. I don't have. Where are my certificates? I don't have them. Let's see apps, AWS, distro. Okay, no, they're not there. That is baselibrary.exe. Where the hell is those? Okay. Code. Okay, keys. Okay, let me see. Snap. What? Desktop documents? Let me see documents. Yes. I think I have. Where the hell are they? Let me see. CloudFront. No, that is CDN deploy. Okay, BR. I think. What? I can't. There's no way I could have any. I could have put that there. I'll probably CDN CloudFront CDN new. Yeah, I think I lost those certificates. So depending on what, so you can request a certificate or you can import. So you can here come import a certificate if you have. So you're going to put a certificate body, certificate private key, chain, and then you go next to import a certificate from where it is you're getting your certificate from, so that you actually have an SSL. So these are things that we're going to do as time progresses. So yes, so no worries, no worries, no worries. This is class is always nice. So no worries, no worries. So you're Shidan, repeatedly you're thinking ahead of time, which is actually good. So it means you have curiosity you need to satisfy. So it makes you a better learner, anyways. So let me go back to Namecheap web hosting. In fact, let me go to Namecheap basic because now it's loading porn up on that in a stacky. Let me go to basic, so that's what meaning. So thanks actually for me logging in. I realized this has my SSL needs to be updated. So with this, hey, $34. Fuck. Okay, ni sawa, ni sawa. Okay, ni sawa. Anyway, see, that is good enough. Let me actually stop recording the class. So recording stopped. Stop recording.